Question 11. It pays to redraw this diagram. It's a little too small to work with. When we draw three-dimensional objects, of course, we try and draw them obliquely. So you can see how I've put a bit of an angle in there in order to emphasize the scenario. I'll draw the rod, or the needle, sorry. Now, we've got this particular box. It doesn't really matter which way around I put these dimensions. The diagram would point towards that being 13. I'll call that 4, and this 6 centimetres. Now what I'm going to do now, I'm going to construct a right angle triangle in the base there and shade that in. Even though it may not look like it, that 13 and 4 sided right angle triangle is definitely a right angle triangle. I'm going to then use Pythagoras' theorem to find out what A is. And once I've got that, I'll work in that needle or side length B right angle triangle. It pays, if you're struggling to visualize this, to redraw it as you go. So A, I'm going to find A, which is the hypotenuse in that base triangle. So you notice that when I've drawn this, I've drawn it flat. So if I'm looking aerially over the top, plan view. That will give me 13.60 centimetres. Now, rule of thumb, if you're not given any direction as to how many decimal places to go, I tend to go 2. Check against the answer as a bit of a guide. Quite often a problem like this will give you direction when it comes to a test or perhaps even an exam. I'm now going to work in the right angle triangle that's formed by the needle to the base of that box. I now know the base length, or A from the first part, is 13.60 centimetres. So it then remains for me to use Pythagoras' theorem in order to find the length of B. The question itself hasn't asked me what B is, it's actually asked me for the longest needle, so I better just write that in context of the question, my answer, context of the question.